Hello everybody, I hope you're having a wonderful day. Welcome to The Most Significant Bit, a podcast where we explore the connections between nature and engineering. My name is Drake, and I will be your host for today's episode exploring how nature is influencing water filtration technology. In our episode today, we will be discussing water treatment technology and how nature has given developers the tools and designs to implement their ideas. One of the important tools nature has given them is aquaporin proteins. But wait, Drake, what even are aquaporin proteins? I thought you might ask that. Aquaporin proteins are little, tiny protein channels that we can find in many different places in nature. We can find these proteins in bacteria, plant, animal cells, and even kidneys. More specifically, they are located in the plasma membrane of living things. I have done some research on some various companies in this study. Allow me to share what I found with you. Let's dig a little deeper into what water treatment technology is. Water treatment technology is technology used to cleanse water through a variety of ways. It cleanses water from particle pollution or wastewater and turns it into usable water we can drink, bathe in, or for irrigation. The most common way we clean water is through a chemical process. This is where they add bleach and other chemicals to the water to cleanse out all of these pollutions. And they take those chemicals back out, and what's left is water that we can use, but there's still some aspects of pollution in there that you can't get all the way out. And there is also chemical residue left in the water, just a very tiny amount. Yes, this has worked for years, and it's been okay for us. But what if I told you we could clean water better without all the chemicals they dump into the water? Yes, it's true. Remember what I talked to you earlier about aquaporin proteins? That's the way they're doing it nowadays. Now, I didn't exactly tell you what they do, only what they are. Through my study, I came across a Danish company named Aquaporin. Wow, how convenient. Aquaporin. They have done a lot of research and development, and they describe aquaporin proteins as highly selective channels that only allow water to pass. Located within Singapore, PUB, or the company's National Water Agency, is in collaboration with the National University of Singapore and Nanyang Technology University, also in Singapore. They have been developing aquaporin-based membranes for the desalination of water. Desalination of water is when they send water from our runoff, our gray water from showers, sewers, and they collect at a desalination plant, and this is where they perform those chemical cleaning systems. One big major goal is to reduce the amount of energy needed to desalinate water to drinking standards. Also in Singapore, the Department of Chemical and Biomolecular Engineering at the National University of Singapore. They are researching the use of human kidneys and mangrove roots to make stronger, more durable membranes that can last up to degradation a lot longer than just regular aquaporin proteins by themselves. To end off today's episode, I will leave you with a very interesting fact. At least I find it interesting. While researching, I came across another company, a Norwegian company, called Sorbwater Technology. They're also using aquaporin-based proteins, but in a different fashion. They have developed a seaweed-based flocculant process to recover water from oil pollution. If you don't know what flocculants are substances that promote the clumping of particles together that can then be removed easier. Ready for the fact? By using this process, they can recover polluted water from up to 5,000 parts per million all the way down to 1 part per million. Now to me, I think that's pretty mind-blowing.
Be carefree lately, just picking up daisies, got one too many.
In today's episode, we covered nature's role in the development of water treatment technology and its vitality. As always, nature will give us the solution to environmental sustainability in the world we're in today. What do you think of aquaporin proteins? Do you believe we should be spending more time and more resources developing this technology? Once again, my name is Drake. This has been The Most Significant Bit. Thanks for joining us today.